Um, yeah, so today, and for the introduction, I'm Daniel. Today I'm going to talk about making sense of Twitter at Bloomberg. So I'm going to present a bit around our Twitter-based products in the terminal, and then I'll also touch upon some research that we've done at Bloomberg using Twitter data and for our product. And I will probably overview I will detail present two papers in more detail, and then I will reference you to other kind of relevant work that we've been doing as well. And if you have any questions, I have the chat open. Please write on the chat and I can take them, or I will make breaks every kind of 10 minutes or so for questions as well. Okay, so I just want to start by telling you about the Bloomberg terminal, which is our Bloomberg's main product. So the Bloomberg terminal is software that delivers a diverse array of information, news, and analytics to facilitate decision making. So this would be kind of the one sentence summary of what the Bloomberg terminal is. The Bloomberg terminal has around 350,000 subscribers in the world, and it's used mostly by financial professionals, anyone interested in investment and capital markets. And it's also tailored either for individual and enterprise users. This terminal is built of many applications. As you can probably see here, there's kind of like a lot of different charts. So we have in each of these is an application which we call functions. And the terminal contains over 10,000 different functions, and you can view these as kind of like in the kind of separate functionality. So using these functions, for example, we can the Bloomberg terminal can deliver real-time news, can show market data, can show messaging. So we also have internal messaging tools, emails, calendars, all of this kind of functionality. We also compute a lot of analytics on our data, as you can see here. And the Bloomberg terminal is also an aggregator of information. So probably you might have heard about Bloomberg as a media company as well, or a media division from Bloomberg News or Bloomberg TV or the magazines that we publish. So we generate content, but we also aggregate content across a variety of sources. And that includes social media as well as other local newspapers or global newspapers or local newspapers in other languages other than English. So probably, again, because of our product and our kind of like focus on finance, you probably assume Bloomberg is mostly about finance, but actually the strength and main area of focus Bloomberg is the data and analytics that we provide to the clients. As I mentioned before, we are both a creator, but also a consumer of news. So for example, our clients look at news. For example, hedge funds look at streams of news in order to identify different signals, or different investors look at the feeds from news from Bloomberg in order to make decisions or investments. In total, Bloomberg has 20,000 employees in over 150 offices around the globe. A lot of these, maybe more than 10%, are journalists and analysts, but actually even more are software engineers. And this includes over 150 engineers and data scientists that work on AI problems, and these are part of the group I work in. And we also pride ourselves into an increased use and contribution to open source and sponsoring different open source projects and also publications. I'm going to switch my headphones. Just give me 1 second.
Can you make your camera also a little bit up? Your face is partial visible. Cutting in the top. If you can, or if you don't want to, it's also fine. I can't hear your voice. Hello. Yeah.
Is it better?
Yes, it's better. So yeah.
Yeah,
Thank
just
you.
give me 1 second. Okay.
Yeah, sure.
Yeah. So the subject of this presentation is mostly about Twitter, and the first question you might have is why Twitter or any social media matter in finance. So as I mentioned, the Bloomberg Terminal is also a news platform, and it's focused a lot on speed of delivering information. So you want the terminal, in terminal it's quick and easy. Bloomberg and Twitter is a quick and easy way to share news, and where information spreads very quickly, and you get access to collective intelligence. So you not only hear opinions from editors or from news outlets, but also from individuals. And the special benefit that we get from Twitter is we have access to a diversity of sources. So are also, regular news outlets, but also you can get information straight from politicians, for example, or straight from CEOs or other journalists, maybe local journalists that use Twitter, kind of as a way of sharing new information even before that has been published in a formal long news article. And actually, for Twitter and in finance, there was like a landmark decision made in 2013 by the SEC, which is the Securities Exchange Commission, that actually information significant for company finances can be shared over social media. So Twitter is basically a public dissemination area for financial information, which you may also have like if you followed, for example, Elon Musk's tweet around like Tesla being taken private, for example, you would see why that was a problem for this. So just to give you some examples of where tweets actually move markets or have impact on markets. This is a tweet that was sent by this person who was actually the finance minister in Mexico. And if you translate this, is basically he's announcing his resignation as finance minister. So the tweet would translate, "I appreciate the opportunity to have been able to serve Mexico," and then a photo of his resignation. And you can see exactly at the time where he posted this, the markets reacted, and this here is a graph of the US dollar Mexican peso exchange rate. So you can see this kind of increase because this person was kind of trusted and introduced some uncertainty in the market. And this happened here, but also held throughout the end of the day and the next day. Another example is of tweets that move market is in 2015, during the time when Verizon was doing their quarterly earnings report, they were saying that their subscriber base dropped by 130,000 users in the first quarter. And then someone said that the T-Mobile may be the only one that grows this quarter. T-Mobile didn't announce yet their quarterly earnings. And Jean Leger, who was at that time the CEO of T-Mobile, said, "Oh, I guess we'll find out if we increase the numbers." But then he kind of winked, kind of hinting that they actually will report positive change. And if you actually look exactly at the time of this tweet, there was a movement in the market, and the stock price of T-Mobile went up as a result of this. This is maybe a more unusual example. So in 2013, the Associated Press news account, official account, got hacked. And at that time, Barack Obama was president. And the tweet read, "Breaking to explosions, White House, Barack Obama is injured." Of course, this was not true. But on the other hand, this had like this is the chart of the S&P 500 index. During this time, you can see actually that the value of the S&P 500 index tanked for a minute or two until people actually figured out that this wasn't true and this was a hack. And this probably was just a result of automated trading that was happening of Twitter.
Excuse me, I have a question. Can you repeat what was the number that went down?
Oh, the S&P 500. So this is the index of the most of 500 top companies in the US. So this is like an indicator of the economy.
Oh, okay. Wow. Okay. Thanks.
Maybe I'll skip this one.
I have a small
Sure.
question. So if you go back to the Jean Leger's T-Mobile season, yeah. So it seems like if you just want to look at the sentiment of the tweet, that wink at the end is pretty important, right?
Yes,
So,
it's very important. Yeah, that's the actual giveaway. Yeah.
right. So this, it seems like very subtle hints like these these small smileys and all, these are very relevant to.
Yeah, and world context may also be very relevant. So
Exactly,
this is
yes.
not an easy thing, but giving basically, I would doubt, or you would need very sophisticated methods to be able to automatically look at this. But at least, like in general, the goal of this entire presentation is us showing, basically showing how we can narrow down the content from millions of tweets published every hour to a few select tweets that are actually actionable and people can make decisions. So it's basically not mostly around, you'll see most of my presentation is not around automating stuff, but more filtering and bubbling up relevant content.
And maybe another question, how do you get the feed from Twitter? Is it like, do you have sort of contracts with Twitter?
Yes.
Or okay, I see.
Yes, we have a large contract with Twitter, so we get the feed in actually very low latency. And actually, if you look at named entities, for example, or the pipeline that I'm mentioning, sometimes like actually we publish, and this feed that we are building and we are showing to the terminal also provide to our enterprise clients as a feed, and actually they get this information even coming from Twitter to us parsing it to them. It arrives sometimes quicker than them getting the information straight from Twitter.
I see. Okay.
I have one more question. So do you so there will be sources of information from multiple, like you said, CEO, journalists. So you look only at the verified account kind of thing, or at the public sentiment also? Like, because if a crowd is talking about
It
something.
depends on the applications.
Okay.
I'll get to this later.
Okay, awesome. Thanks.
Okay, yeah. So we've done some studies on who breaks news first, because there's a lot of examples in which Twitter is faster at breaking news compared to regular news wires. And this is from a paper from back in 2014. At that time, Google Plus existed, so it was a while ago. But basically, we saw there actually most stories break first on news wires, but actually Twitter is better at some type of content and actually lags very little overall in reporting news compared to the regular news wire. And this may have changed as well since then. So this is kind of like our overall pipeline for processing Twitter. So we get the feed from Twitter. We have like a spam, I put it in quotes, a spam filter, because it's more like a kind of relevant to our clients filter. Then we have different models that tag tweets for topics. Then actually, I should say we are mostly interested in two types of content. Well, three types of content, I should say. One is all content from a specific set of users that we deem very important. Like these are the CEOs, these are your journalists, and so on. We also are interested in topics that may impact markets. So this may be like hurricanes, natural disasters, coronavirus now, or so on. Or tweets about specific companies. And this is where entity linking comes in. So we need to be able to link tweets and in general news to entities. And based on that, we can detect trends and show them to clients. And then we also have a filter for newsworthy content that actually then shows up brings up the content to our journalists, which monitor it for other reasons, like writing news stories of their own, or just for promoting it to our clients. And then this gets showed up in the Bloomberg terminal. In terms of Twitter, I'm going to emphasize some things that we have been working on for a while. First is named entity recognition, and in named entity recognition, we particularly focused, and these are, I would say, like one-slide summaries of papers that members of the team wrote. We mostly focus around on different experimental setups compared to kind of your usual tasks. So one thing we're interested in is high precision NER. So if we have clients that trade on this information, we want to reduce the number of false positives. So for us, precision is maybe more important than recall would be. And in this case, in this study, was published at ACL last year, we focused on a specific entity type, in this case, organization, and trading of precision on other types to improve precision on this particular type. And the motivating example of this was, I'm not sure if you remember, in 2017, Bill O'Reilly was this kind of talk show host at Fox News. And there were a lot of allegations around sexual harassment against him. And at some point Fox announced that he's not going to be part of the company anymore, not going to make the TV show. And people reacted positively to this because he's not making the show. And then actually there's a company named O'Reilly Auto Parts that actually started seeing this spike in stock price. So this would be kind of like your regular index. And this is the value of this stock throughout the day. And then actually, if you look more closely at this was probably stemmed from a named entity recognition error and also linking. So this name was linked actually to a company with the same name. Another thing we looked at, and this was published at ACL this year, was around identifying and accounting for temporal drift in NER models. Because normally when we train the model, we deploy it, we start using it in production, but the distribution of the data changes. So maybe we have, you train something, and then after 3 years, probably you will figure out it's not probably doing that well because the language has changed and the entities that are being mentioned have changed. And actually, this is an example of one of many examples, because probably in many real-world applications will be impacted by this temporal drift. And in this paper, we focused on named entity recognition. We introduced a new data set that covers, I think, 6 years of Twitter content. And basically, we proposed here kind of simple methods that try to account for temporal drift if your evaluation setup is testing on data from future unseen time periods.
I have a question. So this temporal drift, why do they happen? Like, it's because of the association of people has changed. For example, the president of some country has changed, or?
Yeah, that's a good and also hard question. We have some analysis on it. It's mostly, so in terms of named entity recognition, usually there's two things: either the distribution of the entities has changed, or either the context in which they're mentioned. We can see a bit of both, basically, but there's more analysis on this in the paper.
Thanks.
Yeah, and then another setup that we have for named entity recognition, and again, this was work with some colleagues from our team at ACL this year as well, was around domain adaptation. But basically, rather than focusing on a single source, single target experimental setup for domain adaptation, where you have a domain with a lot of where you have a lot of annotated data, and you want to improve performance on a domain where you don't have enough data, we introduced 3 experimental setups that basically test the ability of an NER model to use data from multiple domains, and in itself tag data from multiple domains. So here we have 3 experimental setups where we basically compute performance of one model across multiple domains if the domain label is given at inference time, when the domain label is not given at inference time, And this is very akin to how someone would actually use, I would say, an NER system. Like someone has a piece of text, they don't need to know anything about how the model was trained or what data sets were used in training and which one is the most similar to his. They just want to send a document and us inferring and the model inferring the best models for it. And then we also measure generalizability across data that was from domains that were not seen in training, and experiments with all three of these are shown in this paper. Just to motivate here, this is the performance that you normally see in Kono. So this is 90, but actually, you can get 93s right now on this. But if you apply it on public data sets, so this is on the Twitter data that we introduced in the other paper, this is 44% if you apply it off the shelf. So the transfer is not great at all.
Okay. I have a question. So many things in NER also depend on the type of data. Like for example, if you have short text, it's more simpler compared to if you have a long document. If you have a medical domain, for example, then it's more harder because the vocabulary of the current data set and the pre-trained models may be very different. So do you observe these kind of things also, the length of the text, the domain? Actually, you said only like domain is very significant in some say, like which makes this problem challenging.
We have different, so Twitter are going to be like one sentence. We also have, I think, broadcast news that are going to be like short sentences. This is just one factor. I feel like this is one factor, but I think the more important one is going to be the structure of the text. So we see like a lot of issues with models on very long documents because we're tagging company filings, we're tagging transcripts, I think called transcripts, which are very long and very different in style. So conversational versus news versus colloquial. There's a lot of dimensions, and I think, but even if you look at Conal, which is basically news, Reuters data, and if you look at broadcast news, which theoretically should be the same, it's basically like Wall Street Journal versus Reuters. It's still like over 10 points drop.
Interesting. This plot is very interesting. Thanks.
Yeah, and then after we're doing name identity recognition, we're doing disambiguation. And for disambiguation, we also have some work that was introduced by some of my colleagues at NACL in 2018. The task here is collective entity disambiguation with fixed candidate generation. So as you know, named entity disambiguation usually consists of two steps: the candidate generation phase and the ranking. And the ranking can be done collectively across all the entities. In the document, you have multiple entities, and this is usually the case for news, less so in terms of Twitter. So basically, this is treated as the task here in this paper is treated as structure prediction instead of mention level classification. And for this purpose, my colleagues introduced structure gradient tree boosting for this task. And they also introduced, in addition, they introduced this bidirectional beam search with golden path to perform approximate inference in this. And basically this with the goal of reducing model variance here. So if you look at the performance, and this may be a bit outdated because it's from a year ago, still you can see these in green. These are our models. So if you're using gradient tree boosting, gets 88. If you start doing the structure, it's going to be a pretty significant boost to 91.7, which was almost on par with the state of the art at that point. And once you introduce the bidirectional and the golden path, you're already getting almost 1 point better than the previous state of the art. And this is again given candidate generation, so that being fixed. After we're doing named entity disambiguation, we are also looking at salience, entity salience detection in news stories, and you may wonder what this task is. So this is an example of a tweet. Amazon suspends top entertainment chief price in wake of harassment claim. This is a ticker symbol, refers to kind of the stock of the company. And this is written by Hollywood Reporter. So if you look at this, if you read this document, actually Hollywood Reporter just reports on the story. The main actors in the story are Amazon and this person named Price. So you would if you would be showing this kind of like as a trend or as analytics, you would maybe want to discard Hollywood Reporter because the story is not really about them. So this is where entity salience detection comes into play, and we do some filtering based on salience as well. And for modeling this,
just a question: is this task similar to a role level?
It is related. It's not. I would say it's related because again, yeah, if you're looking at this, usually in a tweet you would say, oh, probably the subject or the main actor is going to be salient. But I would say in tweets is a bit simplified because we also do this for long news documents, and then you have multiple levels as well, more than 2 levels. Tweets being short, it's probably just yes or no task.
By multiple levels, you mean?
Multiple levels. So high, medium, low, lower.
Okay.
Multiple levels,
yeah.
Yeah, but I think the role of the entity is a major feature. So the way we've been modeling this is using the regular kind of BiLSTM CRF architecture for named entity recognition with both word embedding and character embeddings. This should be the character level here. And we've introduced this multitask approach where we're doing both named entity recognition and named entity salience in tweets at the same time. And we see that this actually helps even improve the performance of named entity recognition alone. We don't have a paper for this, but let me know if you want to hear more. So these are some of the applications, some of the ways in which we expose Twitter data to our clients. First of all, we have Twitter feeds that clients can create, and they can create like scrolling feeds based on different topics or based on different companies or portfolio of companies, or just general searches. We also do clustering and summarization. And this was originally designed for tweets, but actually we've migrated this for news as well. So basically, if you're looking at a topic like energy here, you can see clusters of stories that were written in the same day with also some popularity score and an automated generated kind of like summary of the story. And I just want to highlight that we had a demo, my colleagues had a demo at ACL this year around this system. And this is the paper that mentions it. I think the main way in which Twitter data is used for company alerts. So if you're an investor and you have your portfolio of companies, you would want to be alerted in which ones, for example, get trended or see more volume than they usually see. We also have sentiment scores. So here, for example, for Tesla, you can in blue bars, you actually see the volume of tweets that were published about Tesla. And of course, this is using entity linking. You can see then you can superimpose different metrics. I think this is the stock price here, and then you can also look at sentiment at the bottom around the company. Computed from Twitter, and again, probably one of the more frequently used screens is this trends screen. And here you can see the companies that have seen the highest increase, and you can select the region, you can select the number of the time window in which you're looking at, and other things. And then you see kind of what are the most talked about companies in this day was Heinz, I guess. Yeah, and clients also have access to a social monitor, it's called, in which they can actually publish tweets and follow other lists of people. This is a bit strange, but actually a lot of companies restrict twitter.com. So a lot of clients actually use Twitter through the Bloomberg terminal to publish their content on their accounts as well. So I think I'm wrapping up this section. Just kind of like a takeaway. I think just in general, the Bloomberg ecosystem provides a lot of unique data challenges and also opportunities for kind of new modeling approaches or new tasks.
that we can think about, mostly focused around latency and around precision. The challenges that we face are usually around modular architecture. So you saw there kind of a lot of different NLP components kind of put together to form part of a larger path, or like split into different paths to service different types of users. We usually have constraints on speed and quality for each individual task. And a big part of this, which I didn't really touch upon, is a lot of these workflow feed into human workflows, or are fed as input to human workflows. And Twitter is just one such source of data. It's unique because it provides a pulse of the crowds and also information that's not available otherwise. And you saw how market moving news actually breaks on Twitter through a few examples.
I have a question. So with sort of the markets being, the global markets being sort of very connected with each other, so how do you integrate data from other languages or from other sort of continents, where, let's say from Asia, you have different languages, but the companies still have businesses there, investments there, but how do you integrate data from those languages?
Yeah, that's a great question. I think this is actually because at Bloomberg we already have, even before we started doing all of this processing, we have actually rule-based systems that provide some level of tagging, but they are very limited to tagging other languages. So I feel like right now we have our services internally work on 3 different languages, so English and Chinese and Japanese. And this is going to be kind of the major push for us because we see like a lot of advantage there of using statistical approaches, basically.
I have a question. So do you also sense like how people actually company use and benefit from the terminal? Like what could be their motive behind, or different, any like some examples if you have, or where they use it, like what they behind it, like?
Yeah, I mean, I've been in a lot of client meetings, so I think there's two main ways in which people use them. First, like some people or companies use it for kind of like automated trading or semi-automated, and then a lot of people use it for, so basically they look for breaking stories, and actually that's a big thing at Bloomberg, like whether we're the first to break a story, even if it's just like a quick headline, oh, someone said something. It's very important that that's very fast, rather than, for example, maybe New York Times that want to write, an analysis story on this or something for wider consumption. So this latency is very important, especially because people make decisions on the fly based on this. So this is kind of the one angle. And then the other angle is mostly people who do research, who want, to invest in a new domain and are looking for a company, and they want to kind of drill deeper and so they can come up with a hypothesis or explain. For example, there's others that some company kind of tanked in stock price, for example, and they want to explain why that happened, so then they know to calibrate that in the future. So I've seen a lot of these actually in client visits, when people were basically, traders were getting calls, oh, why did this stock price drop all of the sudden? And then he was trying to make up quickly a theory about why that happened and if it's like a bigger problem for them.
Thanks.
So in your NLP modules that you just showed, and even in your recent papers, I did not find any mention of using pre-trained language models like BERT. So is there any specific reason for that? Like, is the speed a reason for that you are still going for BiLSTM and CRF-based models and not pre-trained language models?
I mean, for named entity recognition, BERT is not actually the best, the state-of-the-art model for this. We use like the FLAIR embeddings with the BiLSTM CRF architecture. That's also faster. Yeah, that is yeah, so latency is a concern for BERT, although we are looking to see if we can speed it up for other applications. But actually, for named entity recognition, which has been kind of my I would say my key area of focus in the last couple of years, it doesn't actually provide the best performance. So, a combination.
Okay, even if I do not consider the sequence labeling tasks like NER, if I take the Twitter sentiment analysis, for example, I mean, do you have any comment on that? How do you do Twitter sentiment analysis? Whether you do it at a sentence level, or you find out the entities or the aspects in that, and you do an aspect-based sentiment analysis?
We do target-based, okay. Where the target is the company, usually because people are interested in companies mostly. I can't go into details about what exact methods we use or what, but I would just want to say that the definition that we use for sentiment is different to your regular consumer sentiment. So I don't know, Tesla moved jobs from the US to China, probably is negative sentiment, but it's probably good investor sentiment because they're optimizing their price.
So your targets are fixed. You are looking at specific targets.
Our targets are all companies.
All companies, okay.
All the companies.
Thanks.
Okay, I'll move to the next. So should we aim to finish at 3 or you're muted, Vivek.
So we can go 10-15 more minutes. It's not an issue, but definitely like finish by 15 minutes more.
Just want to know how to. There's a lot of good questions. I'd rather us discuss around the questions than trying to go over the material I have. So I was going to in the next section I was going to go deeper into one application, one of our applications, and this is actually like an internship project that I've done with Alakananda Vempala, who's actually full-time now at Bloomberg, and it mostly came out of basically one of our products, which was the social monitor that I've shown before. So in the social monitor, actually, oops, can you still see? I think my screen got disconnected. Yeah.
So I can see the screen.
Okay, yeah, I couldn't see nothing I can. Yeah, so one of the motivations for this is basically these are two feeds. They're both the feeds from Donald Trump, and one is 2010 and one is 2019. So just eyeballing here, you'd see there's actually a huge difference. And the huge difference, in my view, is that a lot more tweets recently have been containing images or other multimedia information like videos or links to other stories and so on. If you see into 2010, it was just basically kind of raw text here. And actually here we estimated in the paper that approximately 20% of all tweets are now accompanied by images in Twitter. And this means embedded images, not even like links here or videos don't count towards this. And 12% may sound less, but it's actually more than 50 million tweets a day. And we know very little about the relationship between the text and the actual content of the image. And here we basically try to look at a few examples. And again, it's from the same Twitter account of Donald Trump. So you can see here, this tweet reads, "A great crowd of tremendous patriots this evening, all the way back to the Washington Monument," and the picture showing basically the crowd of people, Washington Monument, and so on. So basically here you can consider the text is the caption of the image, more or less. And I think a lot of papers make this assumption kind of explicit, where they look at hashtags, for example, and they label images with hashtags and so on. But there are other types. Here, if you look at the text, this reads, "Thank you, MAGA 2020," but then the image says 50% approval rating. So here, actually, the text, I would consider it as being a comment around the image. And also, this is another example. And also, all of these are taken like from within a few days difference from the same account. So this is "Happy birthday to our great Vice President, Mike Pence." And it's an image of Mike Pence with Trump, basically. So here, the image basically illustrates is used to illustrate part of the tweet's text. And getting back to kind of how this came up, is basically clients or users in general of Twitter will see this content kind of as a timeline, and images actually take up a lot of screen estate because they're they're large images. They kind of attract attention, and actually there are guidelines in marketing, for example, that says, okay, you should publish tweets with images because they take up more screen time, they grab more attention, basically. But what we wanted here was basically to figure out a smart way in which we only show images if these are actually really needed and they actually add content to the user. Otherwise, we can hide them by default, and then users can show them, can view them if they really want to. And if you look at the space of an image, each image can basically account for 2 extra tweets being displayed, and with all these big views, a lot of things happening, this actually improves the experience or the amount of information that someone can consume. Again, other applications here, I mentioned also distance supervision for image classification and identifying tweets that contain maybe creative descriptions for images for other applications. So the way in which we tackle this task was to first define the type of relationships that we want to identify. And we split this up into 2 different tasks. One we call the text task, in which the aim is to determine whether there is semantic overlap between the content of the text and the image. And here basically 2 tweets with the same image. One saying Africa's potential workforce will top Asia's by the end of the century as continent wrestle with different demographic and economic challenges. So here you can see some or all the content words in the text are represented in the image. On the other hand, you have a text like, this is interesting. This is actually a comment on the image, and actually if you look at this, the task says none of the content words in text are represented in the image. So the first annotation task just looks at, is there overlap between the text and the content, more or less. And the second task we call the image task. This focuses on the role of the image to the whole semantics of the tweet. And the aim here is to identify if the image contents contributes with additional information to the tweet beyond just looking at the raw text. And the 2 classes here would be the image has additional content that represents the meaning of text and image. So even if there is overlap here, actually the map here shows much more information. Like it shows, the key information that, Africa has higher numbers here, but also shows other regions as well, shows India, for example. So there's much more information than just what's highlighted in the text. On the other hand, the image cannot add any additional content beyond the text. So this text reads, through Bloomberg startup, our employees help to grow strong global leaders, and so on, and just an image of people. This basically adds no additional content. So we looked at these 2 binary tasks. For annotation, we used Figure 8, Crowdflower, or Appen, however you want to call it. For the text task, we collected data with a redundancy of 3. Internet data agreement was 0.71. And for the image task, this turned out to be much more challenging. So increase the redundancy here. You can see the internet data agreement is lower, and we adjudicated the final labels by majority vote. We collected annotations for almost 5,000 tweets, all posted from the same year. We stratified by original post, retweets, and favorited posts, just to get like a diversity here. And we also deliberately sampled these images from users from which we knew their demographic traits, just based on some of my past work, in order to study some hypotheses in how these relationships are used across demographics. And all the tweets are in English, and they are available online, all this data set, if you want to work with it.
Can you go back to the last slide? Like one more slide, yeah. So why did the image task has a much lower inter-annotator agreement? Do you have any insight? Like why is it
it's hard because people
see? that the image contain more, adding more
There are
information?
very fuzzy cases in which someone would say, oh, the fact that is, I don't know, there is a cat in the image, it adds additional information. There are all these like kind of border cases based on how people kind of think that additional information is. I mean, always the image will have some additional information.
Yeah, that's my thought, is like, how will you distinguish, like in the context of the like main content, it's adding some information. Other than like, obviously the visual will have more, can be described in more words and have more information compared to any text.
I think it's mostly about kind of what's salient and what people consider it salient.
Yeah.
In that tweet, and actually the side information actually is useful or not. And that's why it's a bit challenging. And we had actually most of our summer was just spent on trying to figure out these relationships rather than on the modeling.
Yeah, these two tasks are very interesting. I really like them, and I can see the difficulty posed by them.
Yeah, and there's actually has been like some follow-up work since, or follow-up, or maybe I want to say it's follow-up, also kind of parallel thread going on from Matthew Stone and Malike Akhilani from Rutgers, and they have done kind of a similar type of categorization on recipes and text from recipes. And I think there was a paper from Dan Juravsky last year that's kind of like a bit more fine-grained, but their data set is smaller compared to ours. It was just like 1 or 2 conferences after our paper.
Interesting.
So I think this appears to be quite an active area now.
So it seems like in certain cases, just performing the OCR on the images might help. So if you're trying to find out if it is going to add any information to the text itself, you might as well just perform an OCR and just find out if there is any relevant text present. And so that can be one of the sort of the first.
Yeah, we thought about that, but we didn't have time to do it. Okay. I think it will definitely be useful. Like we see a lot of like these motivational posters, for example, with text.
Oh yeah. I see.
So yeah, that definitely is something that is worth doing. We just didn't have time for it. So if you look at the 2 tasks and combine them, actually,
just another small question. So for any of these things, let's say for OCR, would you first maybe just develop a small sort of prototype application of yourself, or would you just go out and maybe use Google's API for OCR for just for testing purposes?
Oh, you mean as my perspective as Bloomberg?
Yeah, I mean
as the researcher.
You guys go and use Google's API instead of just. I mean, I'm asking for the prototype purposes. Do you first use Google's API and then see if it has any value, and then maybe develop your own product?
So I should say, like for things that are central and are very application specific, like entity recognition, we have teams that work on this. For example, for translation, we don't have a team that works on this because it's not really central to us. So for example, in machine translation, we partner with Google, and we have models. We adapt their models to our data, like we provide additional training data. So it depends when this becomes kind of like internal or central to our business or useful in many applications versus not. So for example, translation didn't reach that stage. Maybe we'll never reach that stage, but entity recognition reached that stage a few years ago already. But yeah, we don't usually like spin off teams, invest years until we know this is something the clients will like, because the client base at Bloomberg is very different to any other company. It's a very small, narrow community, and they're a bit kind of peculiar. Yeah, I don't want to say more. Yeah, in what they want. So we first would want to see that something actually helps before we invest a lot of time in it and effort. Yeah, so this is the distribution across the four classes. Basically, we used both binary tasks combine them. So we have 4 possible classes. Actually, they're pretty evenly represented, although, for example, I would have expected, the captions to be a significant portion. So captions will be basically where text is represented and image doesn't add. These are actually just 22% of the data. And before we turn to any modeling, we did some analysis on both of the tests just to see kind of what are the textual features that are correlated to the outcomes. So for this, we did kind of like a simple correlation analysis here. We first look at the demographics because we thought there's going to be some interesting things there. And actually, yes, we found that age is actually correlated with the text being represented in the image. So the younger you are, the more likely you are to post images that do not reflect or are complementary to the text. And to me, this is pretty intuitive, because usually when you have an image that represents something that's in the text, that's kind of like what you would expect. Maybe it's more traditional kind of type of relationship, and that's correlated with older age here. But none of the other demographic variables were correlated. We had like income, age, political affiliation, and so on. And this is some of the textual features. So you can see where the text is represented in the image. You have things like cat, for example, or different feelings like love, congrats, cutest. So usually these are accompanied by images that also show this. While when the text is not represented, you see a lot of like feelings like miss, laughter, or things that are pointing to something like this. So this is something, and then the image shows what this represents. On the other hand, on the image task, again, actually here we don't see any demographic information being correlated to this, but when the image adds to the meaning, again, it's usually the most important one is this. So again, pointing to something or wishing someone well, for example. When the image doesn't add to the meaning, a lot of these like kind of happy birthday to X person, and then the person is illustrated, kind of like what we saw with pens in the example. We also see like a nice validation here around TBT, Throwback Thursday, Tuesday, Thursday. Anyway, this is basically like a hashtag where people kind of show an image and then kind of explain it. So this is like a nice validation of this. And then finally, we looked at some predictive methods. Here, we used demographics, simple metadata, and then we used text-based features, and then we used image-based methods like pre-trained, kind of large-scale ImageNet, InceptionNet, and then we did simple joint approaches. I split here into kind of the 2 binary classifications and the 4-way classification. This is just a majority class baseline here. If we're using the text-based features, we see like some good gains. Then if this is just using the image-based features, and actually we see like here a nice symmetry where on the image task, image is actually pure image information is more useful than the text, while on the text task, the other way around, the text is more important than the image, and then the simple combination kind of gets the best of both worlds and improves kind of across the board, but you can see the performance is still pretty low. And I think this is actually a very hard task. So kind of the takeaways from this section is text-image relationships in the relationship in tweets is complex. The text doesn't always describe the image, and image not always illustrated text. And it's likely useful for downstream applications. So I mentioned kind of like large scale training of image classifiers, and also kind of the case we're using it for, which is direct user facing example. We have a new classification schema and data set for these relationships that's available online. And we saw like some nice predictive results using both the text and the image in the image content. So this concludes this section. I had another section, but this is like more than 10 minutes, so I'm not sure if I should be going over this. So maybe I can go over the motivation and then I can take questions.
Makes sense.
Yeah, so this is again another work I've done for, we've published this at ACL last year. It's around complaints on social media. And again, this actually came as a direct application of the work we've been doing at Bloomberg, because we saw a lot of tweets about companies are around complaints around companies. And then we started thinking about complaints more, and how these are actually different to sentiment and other concepts that are present in the NLP literature. And in general, complaints, we use them daily. People use them daily in their communications. This is an example kind of tweet around what a complaint would look like. And the main question that we had is, what is the goal of complaining? And this is like a regular kind of question in pragmatics. And there have been a few studies in pragmatics on complaining. And if you look here, kind of what's the goal? What's the goal of this tweet? And what is it trying to express? So first of all, it tries to affect positive face. This is really the concept of face, if you are familiar with this in kind of politeness theory. So positive face is the desire of someone to be liked. And basically by complaining, the complainer aims to cast the complainee in a very bad light. So in this case, that Black & Decker basically produces bad blenders, for example, right? But on the other hand, it has another role, which is affecting the negative face. Negative face is the desire of someone not to be imposed upon. And usually the complaint is addressed to a complainee. So here it's at Black & Decker. And aims, actually, one of the aims is usually to impose some reparations from the complainee here. So you would see actually here Black & Decker respond and say, oh, sorry to hear your blender is not meeting your expectations. Can you email you? We want to help, for example. So this, in this case, the complainant actually got some reparations. And then what is usually expressed in complaints is actually, it comes down to this concept of negative mismatch between reality and expectation. So the complaints happen when basically there's a breach of expectations. So here, if this person who bought this blender, for example, was expecting for the blender to make one smoothie, they wouldn't have complained. Their complaint was basically the fact that arose from the fact that they were expecting to make like hundreds of smoothies and they only got to make 5, for example. So again, this is, I think, the main goal, and the main argument we try to make in the paper is that complaints are related but different to sentiment. So in this case, this is a complaint, but it's not really a negative. I wouldn't say it's a negative sentiment toward the company. So I was happy to find out Showtime has an app. Watch all the shows until 6 episodes stops working, right? It is a complaint, but I mean, this user is using this product. They like the product. They just have like an inconvenience with it for the moment. And of course, understanding complaints is useful for a lot of things. It's useful for brands, organizations to figure out what the issues are, and the current customer experience with their products. It's interesting for linguists to understand the types of complaints, because there's multiple types of complaints. For psychologists to study human traits specific to complaining, and complaining here more general. Like here I mentioned about products, but you can have complaints about your spouse, your family life, or something like that, or your time, or your colleagues, and so on. And for NLP applications, it's very important to identify intent, complaining intent for dialogues. So maybe I'll leave this here. If you want to hear more details about what we did with complaints to collect the data, you can look at the paper. In terms of methods, we didn't do anything really special. The goal here was mostly to kind of study this task. So I'll leave it here. And I should show the last slide now that I mentioned, because yeah, we have different open positions for full-time interns. Internships will be available. I think the job description will be available in less than a month or so. And if you want, if you want to hear more information about the work in general, the research, and the different academic programs we have, this is the website. So thank you, everyone.
Thanks, Daniel, and thanks for the last slide also. I think many people would be interested in this. And do feel free to look at the links and even contact Daniel after the talk. And I like the last part, although you briefly covered, like you cannot throw sentiment classifier on everything and get the answers. And there's lots of pragmatic and other aspects involved, and things are displayed in different things. And I think I know how is. I think this is also relevant to your PhD work and also I guess how it's coming out. So, but anyway,
I mean, I have a few ideas and I try to kind of recycle them.
yeah. I can see. Now I can connect a little bit about that. Anyway, so if anybody has any questions or want to discuss anything, we can do that for 5-6 minutes. If I don't know, you have time, 5-6 minutes, Daniel?
Yeah, sure.
Hello?
I have. Yeah. Yeah, I have.
Hello.
Can you still hear me?
Yeah. So I have a question regarding the models for the multi-model part where you have images as well as the text. So I have seen, so there has been some work on so that on visual QA, so where they have tried to sort of get a pre-trained some kind of pre-training with Coco captions. I mean, have you explored anything like that where you do some kind of pre-training with these huge caption corpora available, or maybe just get more data from Twitter, images plus text, and maybe pre-train your models on that?
Yeah, no, we didn't have that much. I mentioned we didn't have that much time to experiment, and this was actually in 2 summers ago. So like a lot of that stuff is like is pretty new.
Yes.
But I think there's a lot of. I mean, we have actually Hao Tan from UNC. He's like an intern with us who was working on visual grounding, visual QA, and we were talking about we can probably test these models out here. Yeah, I think there's a lot of stuff to be done, but yeah, we didn't have time for it back then.
Like multiple multi-model cousins of BERT, visual BERT.
So Hao Tan, one of our interns, was the author of one of those. So we discussed about it, but I guess we didn't have. It wasn't our top priority. As of recently. Yeah, and I think a lot of work. So there's all of this nice work on visual grounding, visual question answering, and there's also this like very nice thread of work that I've kind of been going back and forth with Matthew and Melih on like text image relationships or multimodal relationships, discourse between text and images, or text and news articles is something we've been working on as well. So not only like text and images are not all modalities. We are also thinking like text and reference document, for example.
And so a lot of the times when you see tweets from let's say maybe New York Times or some other financial news organizations, they have a linked article to their website. Do you also sort of explore those articles and find out, because you can actually find very relevant information there, maybe some if it's an opinion post or maybe some breaking news or anything?
So actually you kind of like figured out what one of our research ideas is for this summer. One of our interns is working on this, but I would say like all the news stories, we have them as feeds from New York Times, for example, as well. So basically now we're trying to see like if there's additional information in terms of like popularity on Twitter that can kind of like help augment. The thing is, as I mentioned, the terminal clients are very peculiar. So one of the projects we've done actually that has been most of my work for a year was trying to identify readership patterns around news content so we can better present it. And I would say it's very distinct from what you see in like in general Twitter or general news readership of a newspaper. It's just different worlds, really. Yeah, because there is this kind of like people when they read content in New York Times, for example, New York Times reads it because the revenue comes from advertisement, and they usually have like a model where people, read the stories at the end of the day or something. They have a different model than what Bloomberg or Reuters has, which is basically push out the content as soon as possible, even if it's not well structured. Make a lot of updates.
I have a question, somewhat related to like the visual and image. So many things like are not totally like visual. They are like infographics, basically like a chart, a bar chart, or something like many stories which actually I read on New York Times. They explain the things in a more visualized fashion. And so if you look at the picture, like it's not like something, but they are like animation over a pictures. And so that would also be interesting because that also convey a very interesting story. And do you have any thought of like integrating that along with this thing, and can this be useful?
Again, it's not necessarily news, but we get like a lot of, because in other than news is just like one part of what we get. News, social media, we get like financial reports, statements, research, like equity research documents, of huge variety of content. And actually there has been some work on table understanding. So we have like different teams that look at more of this kind of like extracting structure from documents. I think we had like one of our colleagues, David Rosenberg, had something on identifying from figures in articles, like identifying basically inferring the underlying data behind like a chart, for example. And now we're doing more on kind of like understanding charts, generating text, like summarizing charts, summarizing figures, this kind of stuff. Like we have a couple of teams that just work on related stuff to this.
Anybody has another question?
I have a couple of quick questions on the complaint detection part. So how related do you think is complaint detection with sarcasm detection? And the second question is,
it is
and the second question is that rather than taking it, rather than looking at the problem from discrete sentiments point of view, if we can model the sentiment or model the emotion in a three-dimensional space, like the VAD model, like valence, arousal, and dominance model, then will complaint detection get any help from that rather than looking at discrete emotions like anger, disgust, like that?
Yeah, so great questions again. First, sarcasm. Yeah, it's actually something that for complaints, me and the other authors annotated our data. Actually, we saw a lot of sarcasm there. We actually even labeled it, oh, this is sarcastic, this is sarcastic. We never did anything with it, but yeah, they would be related. But yeah, we didn't have time to look at it. But actually, we have the raw data, so if you want to look at it, I can just send it to you. For emotion, and then second you asked about emotion. And complaint, I actually never occurred to me that I never studied valence, arousal, dominance on this. We tried sentiment, we tried emotion models, and they worked to some extent, but they are still like 10, 20 points off like
the problem with this kind of data which are labeled with discrete emotions is that first of all you get very limited data like that. So there are a few data sets like EmoInt, EmoBank. There are these data sets which have tweets which are labeled across 6 or 11. I think the latest one has 27. I think Emo corpus or something like that. So yes, I mean, but still the data is limited when you think about a single piece of text labeled across n number of different emotion types. So rather than going for those kind of data, it helps if we can represent the emotion or the sentiment of the text in a three-dimensional model, because then we do not depend on discrete emotion labels. We only have to depend on the 3 dimensions of emotion. So we and then we try to so it more works like a logistic regression rather than a classification system. Then
there's more information.
Yeah, you actually predict the intensity rather than the actual true label of what that emotion is. You actually predict the intensity, and probably that has some more nuances
Yeah,
to the actual
yeah, I didn't.
sentiment.
To answer quick, I didn't try this. We tried emotions, we tried sentiment. We didn't try this, even though I'm not sure why we didn't, because it seems, now that you mentioned, it seems something obvious. And we even have we released even an annotated data set with continuous valence arousal labels a few years ago. But to me, so some of the experiments we did with complaints is also using kind of like distant supervision, like from hashtags. That didn't helped very little, even though we got tens of thousands of tweets. And I think it's mostly because of this pragmatic intent. Complaints are very, I would say, have a kind of orthogonal intent to sentiment. They're very peculiar, in my opinion, and they are very domain dependent as well, in my opinion.
Yeah, and
Here
over the top,
we looked at actually we looked in the data set. We have a data set around. It's mostly around products or services. It's across 8 different domains. It doesn't transfer as well across domains, and I'm pretty sure it transfers terribly to personal life or work life or colleagues or something like that.
Yeah, domain does play a role, and then over the top sarcasm detection is a very challenging problem. There are lots of nuances to it, how the discourse is changing from positive to negative, or whether it is changing at all. I mean, the sentiment, whether it is changing from one part of the sentence to another. So
yeah, a lot of these sarcasm, I label them as sarcasm question mark, because I have to, then you need the actual word context, like context around what was discussed before the whole thread in order. You can't even label them in isolation.
Yes, and even the inter-annotated agreement in those kinds of data sets is pretty less. I mean, for the sarcasm detection kind of tasks. Anyway, it was a nice discussion. Really nice meeting you, and
Thank you.
Really great talk. Thank you.
Any other questions? Ashif, do you have a question?
I think I'd just like to say, I mean, great talk.
Yeah, okay.
I sort of now know a lot about the challenges that you have working with. So I was aware of some of the challenges working with Twitter data because of the noisiness, but I know a lot more challenges because you have now the images are involved, and you have so many challenges working with that data.
But again, Twitter is more or less for us just kind of like an outlet also for any better outlet for publication. But internally we deal with these challenges images, but as Vivek mentioned, we have figures, we have charts that are actually even more pressing and relevant.
Great talk. Thanks.
Okay. Anybody else? Suripa, do you want to ask something?
I have a general question actually.
Okay, go ahead.
So with the scale and the speed with which you have to analyze so much data, and Twitter is known to be very biased. So is there a push to have interpretable and fair sort of AI come into the picture when you're doing this analysis?
Yes, I would say we're not there yet, but we've in terms of so you're referring to media bias or
like the data that you'll be using will be put in so much bias that it's bound to have at least some invalid associations, and we know that causes a lot of problems in many of the steps downstream, whether it's NER or anything else, or even textual entailment that I'm sure you'll be using in some part. So is there a step where that sort of interpretability or fairness is injected in?
So I would say I was part of four projects that we have thought about that quite a lot, mostly in terms of diversifying the content that we show. Mm-hmm. So for example, if we look at, if you look at news, basically the main thing that I've been working on was making sure that the same story is ranked similarly, for example, even if it comes from New York Times or a local newspaper, for example, from a different country, for example. So we we put a lot of value on diversifying the amount of the type of content we show and showing like different points of view. I think we'll be doing much more of that, much more of that soon. But yeah, it's something that we know is an issue, but we tackled it in just a few of applications so far, I would say.
Great talk. Thank you.
Hello.
Hi.
Hello.
Yes.
Hello.
Yes,
Good evening.
Yeah.
My name is Aliyu Alige, and I'm sorry I came late to this discussion. I was thinking it was going to be 12 p.m. GMT. I didn't know it was this time. So I guess I've missed like the whole presentation and everything, and that is quite sad for me. But I would like to ask if I may have access to this presentation or recording after this.
Okay.
So that I can look.
Yes.
I message someone if I have some questions to clarify.
Okay. So I think Daniel will ask if he's able to make this presentation public. Otherwise, I think there is a public similar presentation to it, which Daniel was talking about, and I can share that with people. So that's not would be a problem. And he would ask if this can be made public, if this can be made public. And definitely after the presentation, I think Daniel will be happy to answer question over emails, and if he is fine with it, I don't know.
Yeah, sure.
So that
and the slides I can definitely share.
Okay.
And I'll try to figure out if there's a similar presentation, because otherwise I'll have to get approval for the recording.
Okay. Thank you.
Recording the talks also, right? So those will
Yeah. So whether we'll make it public or not, we will discuss that after the talk.
Okay. Thank you.
No problem. Okay, let's wrap up since I think you are also getting late. We extended by around 20 minutes.
No problem.
So I thanks Daniel. It was a very interesting and engaging talk, and I really loved the presentation and the actual challenges involved in dealing with data in the real world, and how do you handle them and how things work. And simplicity, I see, is one of the keys in many of these applications, and it seemed to work pretty well compared to like building or footing a sophisticated model and all. And I guess people also enjoyed. That's why there were so many questions and all.
Yeah,
and thanks again for your time, and everybody else time for attending this talk. If you have any other question, please, I think you can ping Daniel offline and ask. Thanks a lot. Thanks everybody.
Okay, thank you for inviting me.
Thanks.
Bye.
Bye.
Thanks, Daniel. Bye-bye.
Thanks.